Welcome to our lesson on the table saw. We have two table saws in the wood shop, and we'll be toggling back and forth between the similarities and differences of both machines. General safety of both machines and anywhere in the shop: wear your safety glasses all times, take off all your jewelry, do not wear loose clothing, and make sure you have a comfortable working space around the machines. General safety continued on both table saws in the shop. Regardless of the operation, do the entire operation yourself. Never pass your hands over the blade, especially to remove any scrap material or catch one of your pieces that may be falling after being cut. Always have one hand or the push stick on the material to control the material. Never back out of a cut, and the guard must be in place at all times. The arbor, or what the blade is attached to, and the arbor on our second saw. The miter gauge, miter gauge for the second saw is underneath the cart. The fence, the first table saw. The readout between the fence and the blade. The fence of our second table saw. And the readout for our second table saw. The guard support arm of our first table saw. The guard support arm for our second table saw. The guard support arm should only be lowered with teacher supervision and in special cases for large material. The blade guard for our first saw. The blade guard for our second saw. The splitter for our first saw. Splitter for our second saw. Push sticks for both saws. Front hand wheel raises and lowers the blade on our first saw. Front hand wheel on our second saw also raises and lowers the blade. Side wheel on our first table saw angles the blade. Side wheel of our second table saw angles the blade. When you set up the table saw, you got to inspect your material first. You need one face and one edge flat on your material. One face must ride flat against the table and one edge flat against the fence. In this case, I have two boards, and the one on the left does have a flat face, in fact two flat faces and two flat edges. The one on the right side came from the lumberyard rough on 4 sides. This is not flat. If I flip it over, you'll see that it's crowned, and it will also not be flat. The edges are also very rough. This board would not ride through the table saw kindly, and most likely kick back when pressure is put down on one spot or another. This board, anywhere you press down, will not move. The table saw setup continued. The material itself, when you put it up against the blade should be 1/8 to 1/4 above the material being cut, or 1/2, which is about 1/4 of an inch. Using the front hand wheel, we can wheel it down until we reach 1/2 above the blade. Anything lower, it won't cut through and won't pass through the knife or the splitter. Anything higher, unfortunately, is extremely dangerous. 1/2 above the stock. The guard must be in place at all times when using the table saw. Do not ever take the guard or any support arm off unless you have special permission and guidance from the instructor. Only special operations can the guard be moved and the machine be safely operated. The second table saw, the support arm can be loosened and dropped, but just like the first table saw, only when given special permission by the instructor and during a special operation and with guidance from the instructor with the cut. The operations of the table saw include ripping. Ripping is defined as cutting along the material's length or cutting with the grain. Operations of the table saw also include cross-cutting. Cross-cutting is defined as cutting the material's length or cutting across the grain. Beveling is defined as cutting along the material's length at an angle, or cutting with the grain at an angle. A miter is defined as cutting the material's length at an angle, or cutting across the grain at an angle. A groove is defined as cutting a slot with the grain, but not all the way through the thickness of the material. A dado is defined as cutting a slot across the grain, but not all the way through the thickness of the material. Cutting a rabbet is defined as cutting a slot around the perimeter of your piece of material. For ripping on the table saw, our operation procedure 1, making sure that the splitter is in place. Operation procedure 2 for ripping on the table saw, raise the blade to its maximum height. We're using the front hand wheel once again to do this. Using a tri-square, I'm going to put the tri-square flat on the table and put it up to the blade to make sure that the blade is 90 degrees. If it's off just a little bit, we need to adjust the side hand wheel until you see no light against the tri-square and the blade itself. Using the gauge on the bottom is never 100% accurate. Always use the tri-square. For the ripping operation on our other table saw, to raise the splitter, We remove the table saw insert, pull the splitter up, replace the table saw insert. We still want to raise the blade to its maximum height and check for blade squareness to the table. For the second table saw, it's important to have the tri-square flat on the table, not the table saw insert. We can see that there's a slight amount of light between the blade and the tri-square. On this side, we can see the same amount of light. Using the side hand wheel, we can close up that light gap. Now our blade's square. For ripping operation procedure 3, your board must be against the blade, and we want to make sure that we have 1 tooth or 1/8 of an inch to 1/4 of an inch above your stock. Using the front hand wheel, we can lower the blade to 1 tooth or 1/8 and 1/4. This is a safe cut. For our second table saw, the operation is the same. Place your material up against the blade using the front hand wheel. Move the blade down to 1/8 to 1/4 above the material, or 1 tooth. This is a safe cut. For operation procedure 4 for ripping, we need to determine the width of our cut. If our material needs to be cut at 5 inches or less, push sticks are required. If we lift the handle of the fence and we move the fence until our window, our very small hairline, reaches our measurement. In this case, for this example, we'll set it for 4.5 and lock the fence down. This window is for a different gauge on the left side of the blade. 4.5 will be our distance between the inside of the fence and the inside of the blade. For our second table saw, the operation is the same. Lift the handle and slide the fence over. We do have 1 hairline for a readout for our measurement. We get close to our, in this case, 4.5 width measurement, lock the fence down. This is still the same measurement between the inside of the fence and the inside of the blade. Before we cut our material, we need to make sure that the guard is down and that our push sticks are set up. Since our material is less than 5 inches, we're going to place 1 push stick on top of the fence and the other one ready to go on the table. When we turn the machine on, we're going to pull the paddle out from the bottom. Before we push our material through the machine and make our rip cut, we want to make sure that we stand off to the left side. We do want to get up and hug the machine in a sense to get very close. We do not want to stand very far back. We also want to make sure we're not in direct line with the blade, or anything that comes back will hit. If we stand off too far to the right and think we're being safe, unfortunately we can't see if our material is tight against the fence. And if we look over from the right side, then your head is in line with the blade path. To eliminate any issues, stand off to the left of the blade path. When we do start feeding our material into the blade, so I'm off to the side just for a simulation. Once we reach the edge of the table, we're going to replace 1 head at a time with each push stick, preferably the one that's on top of the fence. And this one's ready to go to hook in the corner and push forward past the blade cut. If we stop in the middle and the material is still in contact with the blade, there is always a potential for a kickback. Before we turn the machine on, we want to make sure that the material is not in contact with the blade. We need to make sure that we have a little bit of space. Turn the machine on. Now that I'm on the surface of the table, replace one hand with one push stick, the other hand hooked behind the board, and both pieces, the strap and the good, all the way past the blade and off the table. And turn off the machine. If you have a board that's wider than 5 inches, and I have chosen a very, very wide board, push sticks actually become a dangerous part of our operation. Your hands being able to be both on the board between the inside of the fence and the inside of the blade is a lot safer than trying to use a push stick. We do want to make sure that all our pressure, we know the blade's cutting, so our eyes should be over here against the fence, making sure all throughout the whole edge of the operation, this material stays tight against the fence. If you put too much pressure on the inside and it sneaks away from the fence, there could be a potential kickback. There's really no way to recover that. We need to make sure through the whole operation, all of our pressure is towards the fence as we push the board through. If we use a push stick thinking we're going to be safe, I cannot find a good contact point, and I would be able to push it off of the fence or not push tight against the fence, or try to find a point of center and it would still slide. Using your hands, you have the most control. I'm going to set the saw for 12 3/4. And push the material all the way through and past the blade. I'm going to use another board as a shield for myself because there is a small piece jiggling around, and once I bend down to shut the machine off, there's always a potential for that small piece to come out. This board will help shield that piece from hitting me. We have to make a point also that when we push a board this size through, you can't stand off to the left of the blade path or you're reaching over the blade. Even though it's covered with guard, it is still a dangerous practice. We have to stand in, unfortunately, direct line, but we have to make sure, once again, it stays tight against the fence when we push it with both hands all the way through past the blade. The second table saw is no different than ripping than the first table saw. We do need to drop the guard, and in some cases, we have to have half of the guard up. If you're to use this table saw for any operation, please ask the instructor for assistance and guidance. To cross-cut a piece of material, typically, if it was a fairly narrow piece, we would use the sliding power miter saw. For some of your projects, you're going to end up with a very wide board that unfortunately can't even be reached in width with even the sliding power miter saw. So we're going to have to use the table saw. To start the operation of cross-cutting, we need to first slide our miter gauge into the left slot. We need to raise the guard and raise the blade to its maximum height once again. We've already checked the squareness of the blade to the table with the tri-square. We now need to make sure that we have a square miter gauge to the blade. There is a gauge that shows that we are in fact on 0 for the miter gauge, but sometimes these gauges are not 100% accurate. To be accurate, put the tri-square against the miter gauge and up against the blade. This is one of the reasons why we raise the blade all the way up. When we do it to the table, we have a lot more surface area to be accurate. Here, we have a lot more surface area also to be accurate with squaring up the miter gauge. You can see that we're slightly off. Being tight against the miter gauge, which imagine your board being tight against the miter gauge. If we made this cut without checking, we would be about a degree or two off. If we loosen the handle of the miter gauge, we can simply move the miter gauge around a little bit, and putting it up to our blade, we are now 100% accurate, 90 degrees, and lock it back down. If this is 90 degrees to the blade, your cut will be 90 degrees. For our cross-cutting operation continued, just like ripping, we also need one blade or one tooth above the material, or that 1/8 to 1/4. Using the front hand wheel, bring the blade back down. So we have one tooth above the material being cut. 2, 1. The miter gauge is now square to the blade. Our cut, we're going to shave just a little bit off. When I say shave, I mean about a blade's width. We're going to back our material up, and we're going to get it very close to the blade. Just like ripping, we do not want our material in contact with the blade. At this point, you have to imagine that your board and your miter gauge are one. They have become one. But it is up to you to make sure you hold your board tight to the miter gauge. The miter gauge and the board should go through the blade in unison. Do not push the board any faster than the miter gauge. If you try to hold the board here, it could tip off the miter gauge. If you hold the board here with one hand, you could push the board off of the miter gauge if the miter gauge isn't moving. Imagine once again that it's in unison. I do not suggest holding on to the handle of the miter gauge. I would like you to hold about here where your thumb and your finger are about wrapped around but not held. In case you turn the miter gauge by accident, it will become loose. Keep a hand here. Keep those fingers on the miter gauge, and I would suggest keeping a finger right in the middle slot. This will ensure that you can slide your board and the miter gauge in unison. If you lock your arm, you can make sure that it stays straight through the cut. My material is now lined up with a blade, just about 1/8 of an inch to 1/4 of an inch that I'm going to shave off just a little bit. The guard is down and my material is not in contact with the blade. I'm going to turn the machine on, push the board all the way through, and then we'll check for squareness. You are allowed to bring the miter gauge back without the board. And I'm going to use my board once again as a shield. Now it's time to check for material squareness. To check for squareness, take the tri-square and put it up to the edge and the end of the board. If you don't see any light, your board is square. If you do see light, even slightly, because you do take measurements off of these edges and you use things like combination squares to take angles. If that is off just a little bit, you want to repeat that step until you do find that the material is square. If you do find that it is square, you can jump the miter gauge into the next slot for the next operation. 1. The material I'm cutting, I want it 16 inches long. It's too wide to run through the sliding power miter saw once again, so I do have to use the miter gauge to cut it. I'm going to lift the handle to the fence and slide until our little readout line here in our window reaches 16 inches. What I just did is I'm going to lock the fence down and use the fence as a measuring device. What I'm not going to do is use the fence as an actual part of our cross-cutting operation. Using the fence when cross-cutting is a big no-no. You are almost guaranteed a kickback. I'm hoping if I put this board in here, you understand that that's an extremely dangerous cut. If I did not have the miter gauge in place and I was to try to cross-cut this, it would be all over the place. Trying to feed that through is an absolute big no-no. We understand hopefully that this particular board could be cut on the power sliding miter saw anyway because of its very narrow nature. However, if there is a wider board that you find that you could maybe get away with, it is still an absolute big no-no to try to cross-cut with the use of the fence. You still do not have enough area here to run it through safely. It will almost guaranteed, when that blade starts pushing on it ever so slightly, it will kick. Even a board that is so wide for our operation, it is currently 11 3/4 wide by, it's going to be 16 inches long. When the length exceeds the width, this is where it becomes dangerous. Now, if I were to cut a 2-inch long board at our 11 3/4, you would ask for the instructor help to complete that operation because that's a specialty operation. So if you were to create a cutting board end grain that you need these cut and have flipped upright, it's actually safer to be able to use the fence at 2 inches when cross-cutting. But please ask the instructor whenever in doubt. To continue the process of setting up for cutting our board at 16 inches, you'll notice the miter gauge also has a slight ring or washer to the bottom that slides into the table. Having a board that's this wide, I can slide the miter gauge back and have the board without in contact of the blade slide up against the fence. I can push the miter gauge then tight against the board. Unfortunately, I have 3 points of contact and this becomes a dangerous cut where I have the blade in contact, the miter gauge, and the fence, which all would have to be in 100% perfect alignment for this operation to work. I need to move the fence out of the way, so as long as I can hold this in place, I know it's going to be 16 inches from here, the inside of the fence, to the inside of the blade or my cut. So I simply lift the fence handle up and move it out of the way. Now I don't have that third point of contact. It doesn't matter how far you move it, it's just a matter that you do move it out of the way. Now if the board slips a little bit, the worst thing in the world is it's going to be an angled cut, which you don't want. But at least it's a safe operation that you completed. So now, with the same sense of how I did the shaving over here, I'm going to have one hand around the board and one finger right in the slot to be able to push the material through. The blade is not in contact with the material, the fence is moved out of the way, and the board is tight against the miter gauge. Turn the machine on. Miter gauge, once again, can be slid back without the material. Use your material to shield from the small piece when you bend down to shut the machine off. And And once again, we'll check for squareness. 90 degrees, perfectly squared up board.